Cool.
Rumble.
Okay. Is everyone in from the wait list?
I turned off the waiting room, so everyone should be in.
Cool. Cool. Hello, everyone. Welcome to Developer User Group, sponsored by Intellect. And thank you to Intellect for letting us use the Zoom as well, which is, you know, a proper paid for version, so we can have cool things like slides and no hacking. Great features to have. And we've got some we've got some cool prizes today as well. So if you've got questions or want to participate, the speakers can give out a JetBrains prize, which is a license for any JetBrains product. And we've also got another one that will raffle away at the end of the show as well. If you want to speak, if it's something you want to do and join us, and even if it's your first time speaking, we've got small 10-minute slots which you can get over your fear of Zoom meetings, and you can hopefully at some time in the future we'll be back to live again. But for now, if you want to present, just give us a call on Meetup or on Twitter, and we'll slot you in. Cool. So we've got two really cool talks today. They're quite a lot about new kind of technology, I guess, in a way, for software developers, which is robotics and controllers. So we got Shahzaad first, who's going to be talking about Microsoft's Flow application and how it applies to robotics automation. So I'll let Shahzaad take it away. Remember, if you've got a question or participation, Shahzaad will give out a JetBrains voucher to you. Cool. Thanks, Shahzaad.
Okay, thanks, Bradley. Thanks for having me. I'm going to proceed to my screen. Okay, so today's presentation is about introduction to RPA, Robotics Process Automation, and Microsoft Power Automate. We'll be unpacking RPA and its use cases, and a deep dive into MS Power Automate. A little bit about myself. I'm a technical business analyst at Intellect. I've been about 10 plus years in the IT industry. I've had multiple roles. I've been a software dev in PHP and a bit of C#.NET and ASP.NET, and I've done some product management, and now I'm in the business analyst space. I enjoy running, playing some games on PC and Xbox One, and spending time with the family. Got a wife and 3 kids. Cool, so let's dive straight into the matter of business. So this is the overview. Basically going to tackle what is RPA, the different types of RPA use cases in businesses, and what are the technical considerations. With this type of technology, you also have different roles and responsibilities coming up. With that, there's advantages and disadvantages, and we also look at the software solutions that we are going to unpack with RPA. From there, we'll be going over to MS Power Automate and looking at what it has an offering in the RPA space. And then we'll be taking some questions and showcasing a few demos and what the functionality actually does entail. Cool. So basically, what is RPA? RPA is software that is designed to handle manual and repetitive tasks. The ideal cases should have rules-based, so it shouldn't be somebody's discretion that should be applied to it. So if someone has fulfilled specific criteria, then they should qualify for certain access rights or privileges, etc. So these are more business orientated and they solve actual business problems. So there's attended and unattended RPA. And what that basically means is that you could design a robotics engine to somewhat assist an employee from doing their work. So examples of this is when you have a requirement to pull out various reports from certain systems, and you need to manipulate that data. An RPA bot can go and prepare the data for the individual, serve the data to them so that they can make the correct decisions. There are other ones where they actually go and get the data and require approvals, and an employee will then interact with the bot. So it's a handoff from a bot to a person and vice versa. And unattended is basically script-based, and it interacts with various systems without the need for any human intervention. So at some of our clients, we've been looking at what are the use cases in businesses, right? We've got certain departments like your accounts departments where they are very manual in terms of Excel spreadsheets. They're time consuming, and there's no real, application of work that's actually happening there. So the goal is actually to basically allow people to apply their mind and their skill and their true skill set instead of manually doing this work. There's other instances where there's capturing of customer information. It's a fixed format in terms of files and in terms of forms, but there's been no time to implement systems in order to meet these requirements. So by building these little robotic engines, we're able to capture that data, fill it out in the right format, and give better turnaround time to our customers and save costs. So what are the technical considerations? In terms of security, we will be obviously plugging into various systems. We'll be connecting to external providers, and that means we need to be cognizant of POPI, GDPR, where we are storing the data, who has access to that information. In terms of implementations, we obviously are looking at cloud-based implementations. So then your firewall and your VPN is considered as well, because you need to allow these type of systems to access your environment, and obviously the sharing of that data. If you're looking at your on-premise hostings, you've got to eventually, first of all, have the right systems implemented in terms of licensing and access rights. And then there needs to be a maintenance plan. And the maintenance plan will then require a team as well to be monitoring and implementing new solutions on that. So we talk about roles and responsibilities, and this basically boils down to having a full-on team within or outside of your organization, and that will be primarily responsible for managing these processes in terms of security and support, and performing audits and making sure that everything is met according to regulations. There also needs to be active stakeholder engagement in terms of external vendors, your business teams, and your internal systems teams, as you may need to be plugging, and you most probably will be plugging into those systems. So you'll need the the overview from an architect perspective, the dev team, and your business analysts as well. So what are the advantages and disadvantages of RPA? From the advantages perspective, it's really a time-saving and effective thing to invest in. Your systems will be able to operate 24/7. Your customers will get instant gratification in terms of service, where they request something, they're able to get it within really good times. And it also can be used, as many businesses are actually really looking at. They're really looking at to extend the current system's functionality. And by this, we're actually looking at, there are certain features that are really good, but because the business is moving at such a rapid pace, those functionalities on the existing systems, they don't really get prioritized. So they're somewhat sitting in the middle of that backlog, and they never get attended to. By using RPA in that perspective, you're actually able to extend your system and deliver on a different budget, and be able to make those areas also part of the system. So what are the disadvantages? For many businesses, why they haven't really gone headlong into RPA is because of license costing. If you look at some of the licenses, they can cost hundreds of thousands of rands per year. While that might be, while the benefit that they realize might be much far less, the implementation costs and the additional resources required are also some of the backdrops in terms of RPA. The other one that we've actually noticed a lot that's been happening is that stakeholders may not be keen to cooperate because there's this constant fear that jobs will be lost and that people will not be in control of this. So yeah, that is where we actually find the biggest amount of friction, that they're very, very keen in the beginning, and all of a sudden there's this unknown friction that is actually come about. But that's actually not true, because if you look at it, people are being repurposed, and that's just how life is. There's always new advancements, but then out of that, there's always new opportunities that come out. And that's what we try to embrace, which we call citizen development, where people can actually be upskilled into actually maintaining and building onto these existing robotics engines. Cool. So we look at software solutions. I mean, there's quite a few in the market. Blue Prism has been around for quite a while. UiPath as well. Automation Anyway as well is quite high up on the ranking. And recently, Microsoft Flow has been rebranded to MS Power Automate. And this is one of the ones that we're going to talk about today. Microsoft is going quite aggressively in terms of making acquisitions on existing automation solutions, which I will discuss further on. And yeah, they basically bringing a whole new dynamic to the RPA space. So let's look at MS Power Automate. MS Power Automate is basically an Office 365 based application. It's a cloud hosted solution, and they offer flexible pricing options where you can pay per user as an individual that's logging in your Active Directory, or you can have a per flow plan available. The pricing starts at about, I think, $15 US for a basic flow, which is far more cost effective than looking at your more chunkier licenses like your Blue Prism, for example. So what is their solution offering? They have a multiple solution offering in terms of desktop recorders and web recorders. And what that basically means is that if you need to record a desktop application, you will then use their desktop recorder. The built-in recorder, from my analysis, was that it's a bit limited in support and that it only supports basic MS Office apps. If you go anything outside of that, you do pick up issues. With a desktop recording, the one thing that you should be aware of is that it's sometimes coordinate based. So it will look at the UI elements, it will try to understand it, and if not, it will fall back to a XY coordinate basis. One of the interesting things that Microsoft has done in recent times, it's about 2-3 months ago, is they've gone and acquired Win Automation, which is a standalone application which was primarily used for desktop recording. From my analysis, it's quite a powerful desktop recorder and very intuitive. You can basically automate any desktop application that they are claiming. It is still new, and what they are offering is that the license is integrated. So the moment you log in, you can actually leverage off your Power Automate license on your Office 365 account. The web recorder, which I will be doing a demo today, covers your Selenium IDE. Selenium is known for test automation, and they've basically integrated their solution into Selenium IDE. Selenium IDE will be able to mimic web interactions and basically send that data back. You have the ability to link multiple flows and pass parameters. This I will also explain and show you guys in the demo that we have for you for today. So the biggest talking point about RPA is how can it talk to other systems? And from a MS Power Automate perspective, there are a lot of integrations that are available. So first off, you can integrate into any MS application and your Office 365. You have the ability to go into MS Teams, into OneDrive, your Word and Excel documents. You can even integrate into email. So your triggers could be that if you receive an email from this client database, you can then action it with certain actions in your flow. From an API perspective, they've got a lot of integrations like GitHub, Gmail, your Oracle databases, your social media like your Facebook and Twitter. So you can actually automate even publishing out to your social media networks. The key concern for many corporates is that you're hosting in the cloud. What about data loss prevention? What we have noticed is that when we engage with Microsoft, they've forgot what they call a DLP, which is a data loss prevention policy. And this can be set up in the admin center. So you have complete control over where your data is stored, which plugins you can use, and how and who and what is allowed and what is not allowed to share business data. Cool, thanks for listening. Before I go to the demo, are there any questions from the audience? Cool, I'm going to go on to the demo. So this is basically, I'm logged in on my Office 365 through Internet. This is your MS Power Automate that you can find there. We will go into the flow, my flows, and this is the flow that I prepared for today. What we're doing in this flow is we are actually looking at a website that has a e-commerce backend. We will be able to log into that e-commerce backend, and we will then be able to interact with it. The interactions will be stored on a OneDrive for Business Excel spreadsheet. I'm going to quickly show you guys what the backend will look like. So I'm now physically logging in. Right. This was a free demo on one of your e-commerce websites, right? And we're going to actually click and mimic some logging in there. So I'm actually going to close this and I'm going to run the demo automation, and I'm going to show you guys how the flow system actually works. So as you can see, it's even got a run history, and it shows me as you can see, there's been a lot of failures to success. So let's run it. This, for the purpose of this demo, this flow is triggered manually, but you can have multiple triggers where triggers via email. You'll notice now the browser is opening up, and it's going to be using Selenium IDE to do the testing there. Let's maximize the screen. You'll notice I'm not touching, I'm not interacting with the screen at all. It's all doing it on its own. The data values that are being passed into here are passed via an Excel spreadsheet using an input parameters. It's now searching, it closes, saves, and it will open. So it will do a multiple loop to basically get data, pass the data to that, receive responses, store it in Excel, and it will iterate through this. Flow is still running. Once it's running, it will tell me that it's complete. The other interesting thing to note is that if your flows fail repetitively, this has a built-in system to send you an email as the flow creator to tell you that your flow has failed X amount of times. Please kindly investigate. That is built-in functionality. To set up Selenium, the one thing that you should consider is that you'll need to install the extension on Chrome or Microsoft Edge. Those are the two supported platforms. You will need to install some UI flow extension on your machine so that it can track these interactions. I'm going to go in here to see if the flow has stopped running. As you can see, it says that the flow has been completed successfully. Let's quickly go through this and see what this actually has done, right? So this is the trigger. You could put in parameters here if you wanted. You are able to initialize variables. In terms of, it was actually able to get the input from this Excel spreadsheet. I've actually been able to do here dynamic creation, which I will talk to now when I edit the flow. It was also able to dynamically create a worksheet within there and a table with the date timestamp. In terms of iterations, you will notice that there were 5 rows here and only 2 were actioned, and there was a reason behind that. If we look at our spreadsheet, this is the input spreadsheet. So the input spreadsheet, very simple logic here. We had your order IDs, which we were passing through the browser. And this was going for check order. So the ideal business case is here is that you have X amount of orders. You want to check what are the status of those orders. And there are certain ones that you want to check on. You can either mark a yes, no as a flag, and then the decision will come in terms of your logic there. So I'm just going to move that there. So let's go into this thing here. So this was the UI flow that was triggered. It was triggered via the browser. It had some results set there, and then it was able to add a row to the table. What's very interesting to note is that there's almost some sort of like a JSON type of formatting that's put in here so that you can actually go in and actually edit some of the stuff. So if I go into edit, this is where you can actually initialize your variables. You have your little for loops that you can customize here as well. I've put in some conditioning logic in here. And from there, you can actually link to an external UI flow. You'll notice here from here that you can actually pass parameters. And if you hover over it, it actually gives you the basic syntax that you can use. And here you are actually able to manipulate the flow. In terms of the output, we'll quickly look at the output. So this was basically a single spreadsheet, and this spreadsheet was able to, apologies, that's this thing here. You notice that the spreadsheet is basically dynamically creating tabs here and exporting data here. There is a little bug with this flow. It pulled out the entire one there, but the point was that it was actually able to receive this data and pass it through here. Cool, that's it from me. There are other features here in MS Power Automate, but I think that will warrant a much longer discussion. There's a built-in AI builder here. This AI builder is able to scan receipts, measure people's facial sentiments based on the AI technologies that they've been using. There are external connectors. Let's go to the external connectors here. These are the connectors that you can connect with. These are the plugins that you can use. You can connect to Twitter, your SharePoint, your Power BIs, your Google Drives. In terms of data, there's a common data service, which means you basically don't need to access data directly from the database. You can actually build some sort of what they call a cache. So if it's like your provinces or cities, you can basically take that data, put it in here, and from there retrieve that data, so you don't have to make unnecessary calls to your database, improving your time. Yeah, but that's it from me.
Thanks, Shahzaad.
Cool. open
Oh,
up,
sorry. Go
allow
go
people
ahead,
to
Henrik.
unmute themselves if they want to ask some questions, or they can type their questions as well.
Sorry, yeah, I just wanted to find out if you could show us that actual UI flow, because I see you run it there based on the condition, but can you actually show us that UI flow?
Yes, certainly. So yeah, for the interest of time, obviously I didn't go through the UI flow. Let's quickly go through that.
Sorry, I'm just very
Wait.
curious.
Yes, no problem. Sorry, I have to share my screen. Cool. Can you see my screen?
Yep.
Okay, cool. So this is the actual flow that I talked you guys through now, right? And when I went to edit, you could see that I could link to the UI flow. So here's the actual UI flow, right? So I call this one card, not card, but yeah, anyways. If we click here, so this actually opens up Selenium.
Okay.
So with Selenium, you can basically click, I'm gonna make this obviously slow so that you guys can see what happens. You'll notice here that you are able to pass in variables here. So let me actually just minimize this. It's so much nicer when you have multiple screens, eh? Just trying to think of how I'm gonna do this. Oh yes, yeah. So when I linked in the flow, so you see it's order ID. So in terms of the moment I add something in here, so let's just, you'll notice here I was doing some test data. So I would put in 15 here. This is commented out. The moment I uncomment it out, it will basically appear there. So if I had to type in $, test bar, and if I had to click save, right? And if I had to go out of this flow, edit this flow. Yeah, you have to come out sometimes because it doesn't pick up those changes immediately, you know. And there's my test var. So it's actually listening in on your updates that you do on the other side. So yeah, so that's actually how you do the UI flow. So the way I did this one is first I recorded the UI flow, right? I recorded the UI flow and then I built all my logic into the main flow and then just referenced it there. What's also interesting is that you can actually, if you know Selenium well enough, you can actually put more information here. So for example, you can say insert new command, right? And this is the new command that's there. And you have a whole list of options here available. So you can like tweak what you need to do here. You can do little echoes out here. You can do mouse interactions. So yeah, there's quite a few options that you could use here.
Okay, so the whole point of the power thing is that you can actually split out your UI input or your UI flow from your actual logic.
Actual flow, yes.
So
yeah, so this is actually the RPA part. The other part is more your flow interactions, and they basically handing off and leveraging of each other. And that's how they talk to each other.
Very cool.
Yeah, the desktop recording app, we had quite a few struggles with it, but I thought that the web one was more prevalent and more useful in terms of that there. The other thing, because we sometimes sit within certain corporate environments, everything is protected by the VPN, right? So you're going to really struggle in terms of trying to connect. So let's give you guys an example here. So if I just say, instant from blank, menu trigger flow, just click on create there. You guys can still see my screen, right?
Yes.
Yes.
Cool. So this gives you now all the options, right? Premium is where you need to start paying for a license. So I've obviously got a trial license, which is 30 days, and you can set up multiple environments. So you can set up a sandbox environment, a production environment, etc. In terms of this with the built-in, you can actually do web requests and schedulers and webhooks. So there's quite a few cool options that you can play around with here, right? In terms of your variables, if you click on variables, for example, you need to initialize a variable. When you click on initializing a variable, you can choose your type, right? And then you can put a variable. So let's put that there, my var, right? And then you can even rename this. So you can rename this and say my var right there. What I think is really awesome about this is that for anybody who's learning how to code in the beginning, and that's why I say citizen development, because you can actually start teaching the business people how to code. You know, if they have a little bit of logic, which I'm sure most people do have, you can actually start upskilling them. And I think it's actually great because when you're discussing with them technical stuff, they're kind of getting to know a little bit of stuff. Yes, they don't know, the intricacies of object orientation, etc. But I think this is a good starting point for them. What's also very nice is in the moment you click on this, you get to have like dynamic values and you have functions, right? So if you want to say, see, as you typing in, it's automatically coming up with values there. And you can say timestamp, and then you can put in the timestamp, and then it will basically give you a timestamp. If you say list functions, this is obviously going to take you to the MS thing, and they've got a whole lot of functions that you can use here. So yeah, so you can actually do substrings, concats, and that's exactly what I did here in my flow, which I've got to show you guys. I'll leave this there quickly. So what I did to make mine, my flow quite dynamic was that I initialized a variable called table name. And if I'm going to hover over here, you're going to see a whole lot of gibberish there. Basically, I'm taking a table name and I'm basically taking the date timestamp and I'm manipulating the formatting of the string, and by removing that data and then making that my table name. And from timestamp, I'm also replacing those dashes because the dashes will probably be illegal in a MS Excel table name, and I'm basically replacing with underscores. So I was actually able here to make a dynamic worksheet based on a timestamp, and the tables are also dynamic in terms of your table range with the timestamp and the table name. And then when I was actually applying the output, you'll notice here I'm actually leveraging of the dynamic tables here as well.
Very
So yeah, so a lot of learning, a lot of fun, because the one thing you should remember is that there isn't much resources on MS Power Automate right now because it's fairly new. There's a lot of researching and Googling around, but yeah, but it was quite fun.
Cool, that's awesome. It sounds like you can do a lot of things. Shahzaad, do you want to ask a question just to give away our prize? Because I think we're probably getting close to time now. And just cool. See who can reply to your question, and then we can give it away.
Okay. Cool. It's going to be an interesting one. Which IDE do we use for web recording? That's my question. Oh, Sean has answered.
Cool. Yeah, Sean seemed to get there first.
First, yeah.
Well done, Selenium. Sean. You got yourself a JetBrains prize. Thank you to Jet for sharing that, and thank you, Shahzaad, for that presentation. It was fantastic. I think it's like a great way, like you say, for even business people that are busy doing repetitive tasks to get into automation and programming and upskill themselves. Cool. Thanks so much. And
there is a question.
Hopefully we can have some more.
There's a question from Sean. It says, do you think this is enterprise ready? So that's a very good question. Yes and no. The reason why I say that is that Microsoft has released this, and they're basically going with this off the bat in terms of whoever engages with them, they're ready to engage with them. They've engaged with our client because we've shown some interest in this. There was a lot of concern regarding the privacy, etc., and they've always had answers. So I think they are getting there. The Win automation is something that I'm now really looking into. So yeah, hopefully I can come back to you guys and give you guys a more clear-cut answer when I see the Win automation and the desktop recording is up to standard. So yeah, I think they are there. They are getting there. But yeah, you remember with many corporates, once you've invested in a software solution, you are somewhat tied to it for a while, and the changeover and the cost of change is there. So yeah, I think that's something that's holding many people back from embracing them. Yeah,
thank you very much for that answer. Yeah, thanks.
Thank you.
Okay, cool. Thanks so much, Shahzaad. And congratulations to Sean. And we're going on to our next presentation now, which is going to be by Cliff. And Cliff is an electrical engineer, and he's been working for quite a while, and has been from the corporate world and started his own businesses, and has a little hobby on the side, which is home automation. And you guys voted for the topic that you'd like to hear about today from Cliff, and that's on the controllers for home automation. I don't know why I was trying to say automation. That's not even a word, but we can make a new one. So great. Once again, if you got a question, just pop it in the chat, and then we can answer that, and Cliff can get back to you. And there will be a prize again during this one. Cool, Cliff, it's all yours.
Excellent, thanks. Hey, good evening, everybody, and thanks for having me. It's a little bit of a part 2 of the talk that I did at DevConf. So for those that were at DevConf, I'm kind of going to dig a little deeper into some of the stuff I talked about there. I'm going to drive the whole presentation through the web view or through the video view. So try and maximize my video screen if you just want to watch along, because there's a bunch of stuff going on here. Right, let me jump into the PowerPoint quickly. So what are we going to talk about? We're going to talk a little bit about home automation, and I think, as Brad said, maybe it's a combination of automate and automation that got his tongue in a bit of a tie. But yeah, we're going to talk a little bit about the actual hardware and the controllers involved in home automation. I guess in some ways that's sometimes the stuff that's a little bit black, a little bit dark. Most of you guys on the call are probably software guys, so sometimes the hardware becomes a little bit of a barrier to entry. So hopefully we can dispel a little bit of that today. Just to orientate you quickly, this is kind of the world we're living in at the moment. This is the whole sort of home automation stack, the way I see it. We're really going to focus here on this first block, on the things, on the controllers, the stuff that create input, switch things on and off, create some output in terms of sensors, etc. And I guess in many ways is the IoT heart of your home automation system. So what are they? They're these little controllers, these little microprocessors. They come in millions of different shapes and forms. This talk would be 2 days if we had to cover all of them. So I'm kind of limiting the talk to 2 specific chips that I really like, and I guess that are most prevalent in the industry right now. The first one is called an 8266, an ESP8266. A little bit of a system diagram up here. Really, I don't expect you to understand everything in here, but the point I want to make is that the 2 controllers we're going to talk about in this talk are incredibly, incredibly capable. They're very small. They're what they call system on a chip. So in other words, they're a fully fledged system on a single microprocessor, and many hardware manufacturers are using this architecture to build hardware around. So The 8266 is probably the most prevalent chip architecture that is used in many of these controllers. The reason people like them is it's kind of an all-in-one. It gives you a microprocessor, it gives you memory, it gives you inputs and outputs. And the thing that's really fantastic about it is it has an inbuilt Wi-Fi stack. So it natively has a Wi-Fi stack that can connect to wireless networks. And that's why we typically love them. It's got a big brother called an ESP32, which I'll cover a little bit in the talk as well. Really, all you need to know about it is that it is the big brother. It's more capable. It's got more inputs and outputs. It's got more hardware capability in terms of things like analog to digital converters. And it actually has a seriously decent processor inside it. Actually, it has a couple of them. And some are dedicated to specific functions like ultra low power mode, where it turns most of its main micros off and runs a very low powered micro for very, very low battery consumption. And so it does pretty well on things like batteries and places where you maybe are using solar to drive the processor. So all of this kind of stuff that we're going to delve into tonight starts with what we call flashing, right? And flashing is effectively the process of programming your microcontroller. As I said, these chips have a bunch of onboard memory, both ROM and RAM. And the nice thing about these things is they accept code in a very standard way by taking the GPIO 0, so an input port on the microprocessor, to 0, in other words, keeping it at a low voltage when the chip is booting up, turns it into programming mode. And when it's in programming mode, all of these chips have a serial port on them. You can send it new code over the serial port. This is interesting because lots of manufacturers create these things and they often come out with their own firmware on. And by understanding how you can program it, you can put your own firmware on these things, which we're going to talk a little bit about. So let's do a quick little demo. Always conscious of time to first demo to try and show you something and kind of get out of the slides. So the first demo I'm going to show you is just how to flash what we call a D1 Mini, which is an off-the-shelf development board, and you should be able to see it in a second. So let's do this, and let's do this. And you should be able to see my desktop at the moment. What I have here is I have one of these very small microcontrollers here. You can see this is the chip that I was talking about. It's hidden under this little metal cap to protect it from electromagnetic radiation, but they do bring out the Wi-Fi antenna. So you can see a little squiggly line over there. That's a Wi-Fi antenna. And that's the size of the chip. So that is a microprocessor, a bunch of RAM and ROM, a whole bunch of input outputs, and a Wi-Fi stack. So I've just got this little dev board plugged into a USB port. I'm going to whack that USB port into my USB port on my machine. And then I'm going to show you my desktop. And you should be able to see my desktop over here. So I'm using a little tool called Node MCU Flasher. First thing I'm going to do is I'm going to go and search my serial ports. And you'll see it's come up with the serial port here of COM10. I'm going to go and browse for a piece of firmware. And this piece of firmware is simply one I downloaded from the web. We're going to get into this firmware just now. I downloaded one called Tasmota, which is one of the most interesting ones that's around. You can go straight to the GitHub page and you can download their latest release. And that's literally what I've done. I've just downloaded the latest binary from here. I'm then going to configure a couple of things. So you need to understand the specs of this thing. But if you want to copy along from what I do, make sure you use dual output when you're programming in these chips. You can choose whether you wipe the entire RAM or not. We're going to go ahead and do that. And then we're going to go flash this chip. And you can see it's now already raised the ROM on the chip. And now it's busy programming a new piece of firmware into the chip. And literally, it's that easy when you have a development board to program a piece of firmware onto the chip. Now, obviously, these boards are made to be programmed. That's why it has a USB port on it. That USB port is doing a serial conversion. It's putting the chip into programming mode. So these are dev boards. They're made to be programmed easily. But they're really, really useful if you want to build something to control around your house. And I'll show you some examples of that a little bit later. Okay, let's pop back to the slides. Okay, so let's talk a little bit about this concept of firmware and what the firmware really is. But the firmware is basically embedded software. It's software that runs on an embedded microcontroller. Most of the commercial devices that you'll buy for home automation come with their own firmware built in. That firmware is typically proprietary to the manufacturers, and if you're kind of getting something made in China, it's probably not the best quality. Certainly sometimes has a lot of bugs in it. Any of you are familiar with the brands like Sonoff or ESP, know a little bit about these firmware. The nice thing, like I said, is that these boards are based on the standard chipset. So these boards are able to be flashed with your own firmware. Most of the nice open source firmware projects are in the name. They're open source. So the source is the two that I really like, Tasmodo and ESP Home, are both on GitHub. Take contributions from the community and really, really active projects. Typically written in C or C++. There is also a Python firmware that people have been working on. But you kind of need to be in the C or C++ world because you really are working in a memory-constrained, resource-constrained environment. It really doesn't do well with higher-level languages like Java or C# that really assume you're working on an environment that has a lot of resource. So the first firmware I want to talk a little bit about is one called Tasmodo. It's based only on the ESP8266 chipset. That being said, the majority of off-the-shelf devices these days are based on that chipset, so it's really highly applicable. It is a pre-compiled firmware, so that means that you can download a binary that the creators have created. And if I just jump to the GitHub page, you should be able to see, if I go to the releases section, you can just kind of see that the binaries are created for you. So if I hit downloads, you can see there's a whole bunch of different download resources here, but you can basically get the binaries in many, many different formats and languages. And their methodology is that they create a pre-compiled binary for you, you flash it, and then you configure the device at runtime. And I'll take you through that a little bit later. So there's no compilation required. You don't need to compile any C or C++. You literally just flash the firmware onto the device, bring the device up and configure the device. The process of flashing requires you to connect your off-the-shelf device to a flasher. So the picture that you're seeing in front of you right now is what's called a Sonoff Basic, probably the cheapest, most available piece of IoT hardware you can get that costs anything from 120 to about 150 Rand, which is next to nothing in kind of IoT controller terms. The nice thing about it is that it comes with a transformer that understands 220 volt mains input. So you can put 220 volts in on one side, and it's got a little switch on-side it, and it sends 220 volts out the other side when it's working. So you can plug it in your light switches, you can plug it on your appliances, you can do a whole bunch of stuff with this thing. These little 4 yellow pins you see here are the little pins that are exposed on the board that expose those outputs that I was talking about. So 2 of them are the serial ports, the TX and the RX port, and then there's power and there's ground. So there's plus, minus, TX and RX that come out on the board, which makes it really, really useful if you want to blow away the horrible Chinese firmware that's on there with your own firmware. And so let's go ahead and do that. And I'm going to show you how to program this thing with your own firmware. So let's flip back to the desktop. And here is that device. You can see I've got it connected to a 220 volt light globe. I then have a little tool. Because this thing doesn't have a USB port on it, you have to speak directly to the chip on it with a little tool. So these little flashing units will cost you about 150 Rand. And really all it is USB on the one side and serial on the other side. So it's a USB to serial converter. If you do get yourself one of these, just be very careful that you choose the correct voltage. Most of these boards work on 3.3 volts, not 5 volts. And most of these little flashing units have a switch on it that can choose whether you're flashing at 3.3 or 5 volts. So just be careful of that. If you don't set it at the right voltage, you will blow away your little controller when you connect it. So I've just made up a couple of wires. I'm going to plug these wires into this board. Like I said to you, in the thing, to get the device into program mode, all you do is you hold pin 0 down, and they've very pushed made this little switch on the board. So this board's got a little switch on it that is connected to pin 0 on the microcontroller. So all you do is you keep the switch pushed down, and then you power the board up while the switch is pushed down. That then makes the controller go into program mode. And now we should be able to see our controller. So let's go back to our desktop. Same tool I used to program the previous dev board. I'm just going to do a refresh here. We now have a new COM port here. Same settings I did before, exactly the same settings. I'm going to wipe all the memory. So I'm going to blow away the nasty Chinese firmware that's on there. And I'm going to put a copy of Tasmota that I've chosen and downloaded onto this. So we're going to flash that guy. And of course, the demo gremlins come out as soon as I do this. Let's just try and put it in program mode again. Now we know it's a real demo. Make sure I aligned the pins correctly. Okay, let's try that again. Just trying to hold the button down and plug the USB port in at the same time. Let's try that again. Yep. Right, that looks better. Sometimes it's a little tricky to hold the button down and power the device when you have only got two hands. So helps if you've got a third person in the room sometimes to just make you a little bit more ambidextrous. So you can see it's going ahead and flashing the firmware onto our device. And if I flip back to my desktop for a second, you'll see this little light over here is flashing away as the serial bits are running out of my PC into the ROM of the device. Takes a little while, a couple of seconds, and then it should report to us that it's finished flashing the device. So let's flip back to the desktop, and you should see that it does a verify, and it says that it's successfully flashed the device. What you want to do at that point is you want to unplug it from the USB port. So you basically want to power down the device and then plug it back in. And after you plug it back in, it will boot your firmware. So now you've basically written your own firmware to that ESP8266's RAM. If you want to see what's going on, now that I've rebooted it, you can use basically any old serial terminal emulator. The one I like is called Termite. And Termite basically just speaks to the serial port. So most of these firmwares expose a serial stack that allows you to speak to the device. And so if I just push enter here a couple of times, you can see I'm getting a nice response. I'm getting a command response now. And this response is coming from the microprocessor that's running inside that off-the-shelf device. Now, the next step you want to do is kind of get this thing connected to your Wi-Fi. So you can do that in one of two ways. What it's doing right now is the device is seeing that it's booted up for the first time. It knows it's not connected to any form of Wi-Fi. So it's actually transmitting a Wi-Fi captive portal, which you can connect to with your phone or your PC to set its configuration. That doesn't demo so well. The other way to do it is literally to type a command into the serial port to give it some configuration. So here is the command. You basically type SSID and the name of the SSID you want to connect to, your password and the password you want to connect to. And you send that into the serial port, and the device will accept that configuration, and it should reboot and then connect to the Wi-Fi. And you can see we've successfully connected to the Wi-Fi. So now if I take that IP address that it's reported over its serial port, and I copy that, and I bang that into my browser, I'm getting a web page served up by the controller that we've just flashed with this firmware. And this web page is served entirely from that controller. I can toggle the power on and off, and I can do a whole bunch of stuff. Now, the light globe, as I toggle power, is not turning on and off because the device is only powered from my serial port. So what I'm going to do right now is show you the desktop again. I am going to unplug the USB port, unplug this, this controller device. While I've got this down here, I'm going to, on these same pins that I used to program it, I'm going to plug in a little temperature sensor. So now we're going to overload this device by plugging in a temperature sensor into the pins. And then I'm going to reach over and put the 220 volts into the input. So now it's no longer powered by the USB port. Now it's being powered over here. I'm not going to touch it because I'm going to jump like crazy if I touch that, but there's 220 volts coming in there. If I refresh this page now, and I hit the toggle button, which you can't see, you'll see that our light has turned on. You can see the light is turned on over there. If I toggle the other way, you can see that it's now turned off. So now we have power on our device, which is fantastic. Okay, let's jump back to the slides. What I showed you was a kind of a nice way to program these devices. In the picture that you see above you here on the slides right now is a light globe, a smart light globe. And when I screwed the cap off the light globe, this smart light globe actually had that same chip inside it. So the image here requires a little bit more work because in these smart light globes, they don't really expose the pins to program it, but there's these little tabs on them where if you're a little patient, you can solder 6 wires onto those tabs, plug it into the exact same programmer that I just programmed my smart switch with, and I can program a firmware onto my smart light globe that I can then blow away again, the nasty Chinese firmware, and run a firmware on a smart light globe. So really, there are hundreds of controllers that allow you to program it with this type of firmware, all because they're based on that same chipset. And if you go to the Tasmota website, you can kind of see all the devices that they have support for. And there are literally hundreds of devices that you can flash your own firmware onto. Okay, so let's dig a little deeper into what this Tasmota firmware can actually do. So let me go and show you my desktop again. Again, here's my smart switch that we just programmed. You can see it's pretty basic at the moment. It's really just got an on-off button, and that's about it. If you hit configuration and you go to configure module, it'll tell you all about this module. So here are all the different, it's got a whole bunch of different templates for all the different types of devices it supports. The generic one is the Sonoff Basic, which is the one we're working on. Here are the inputs and outputs that this board supports. So it's got a serial port that's getting used at the moment. It's got a space sensor port, et cetera, et cetera. What I did just now was I plugged the temperature sensor into the serial input. So if I wanted to speak to that temperature sensor, it's as simple as finding the temperature sensor that I plugged in, and I know it's a DS1820. I'm telling this configuration at runtime now that I plugged a temperature sensor in and I've connected it to that pin on the board. If I flip back to the desktop, over here I plugged these 3 wires in. The temperature sensor itself has just got power, so 2 wires for power and then 1 wire for the sensor. That sensor is plugged into GPIO3. I'm going to hit save here. And now when I go back to the main menu, and I'll show you my desktop, you'll notice that the firmware web page has changed and it's reporting temperature. Super interesting. So with like 2 clicks of configuration, a little bit of wiring, I now have a temperature sensor that is connected to my smart switch. And what I've done in my house is that I've put one of these switches into most of the switch boxes in my house. And then I've hung a temperature sensor off, the same thing that switches the lights on and off. I've hung a temperature sensor, and that allows me to tell the temperature in most of the rooms of the house. So I'm really using one device, a $100 device, to be a smart switch and a smart temperature gauge all in one. So that's super interesting. The firmware itself has a really nice console view, so kind of like a command line for the firmware. And it's really, really capable. It allows you to view things. It allows you to set things so you can type in commands in here. All the commands that the firmware supports at runtime are supported through its console. And it even has a fairly powerful rules engine. So we're going to try something quickly. I'm going to flip to my Visual Studio. So often what you want to do is localize processing inside the microprocessor. So you could choose to say, look, if the temperature got to a certain point, or if there was a motion sensor on this, turn the light on when somebody comes in the room, et cetera, et cetera. The problem with leaving the microprocessor is that you're then kind of dependent on something else. It would be really nice to have some logic running on the board itself. And so this firmware supports a rudimentary rules engine that is actually reasonably capable. So what I've written here, which you should be able to see here, is a very simple rule. It's rule number 1. It basically is saying every time it gets a temperature, if the temperature is above 20 degrees, turn power on, power number 1 on, which is the switch. If the temperature is below 20 degrees, turn power number 1 off. So let's just copy this little rule here. We'll head back to the terminal. We'll just bang this into the terminal, right? Rule 1, same code you just saw just now. We'll hit enter. Okay. And then we'll enable the rule by typing rule 1 on. And that will turn the rule on. And you can see the rule is just executed. Every time it gets a temperature now, it's executing the rule. So power 1, 0, power 1, 0. So let's head back to the main menu. I'm going to show you my desktop quickly. And if I grab the temperature sensor with my finger, you should be able to see the temperatures went over and notice the light turned on. If I let it go, temperature's dropping, temperature's dropping, temperature's dropping, 20.4, 20.1, there it goes. The light turns off. So with a couple of lines, I've built a smart switch that is Wi-Fi controllable, that has a temperature gauge hanging off it, and has local logic to execute local logic all out by itself without being connected to any other device. So I think that's pretty cool. Right, let's go back to the slides. And while I'm going back to the slides, if anybody has a question right now, feel free to break in. If not, we're going to slide some more. Okay. The next firmware I really like is one called ESP Home. It's a newer kid on the block, and it has quite a different approach to firmware for embedded devices. It's based on a YAML metadata language. So what that means is their whole approach is, instead of runtime configuration of your firmware, they believe in compile time configuration. So the guy used the YAML syntax. Probably could have used something nicer. I'm not the biggest fan of YAML, but I guess we kind of get used to it. It's highly optimized, because effectively what he's doing is he's taking the YAML that you create as a configuration language. He's then templatizing that into blocks of C and C++ code. He's producing a C++ project that is then getting compiled into a very specific firmware for your exact configuration. And that firmware is then written to the device. So let's take a quick look. Let's take a quick look at what that looks like. Let's go back to the desktop. So let's bring up Visual Studio. Here's a sample configuration file. So you can see it's the YAML syntax. If you go to his website, which is esphome.net, I think, or his GitHub page, very well documented, esphome.io, sorry, very well documented on how to create the YAML and all the features that it supports. But effectively, what you do is you give your device a name, you tell it some stuff about what chip architecture it is. So He supports a whole bunch of different microprocessors. The nice thing about his firmware is he supports both the ESP8266 and the ESP32 devices, which makes it a lot more capable. You can see here's my Wi-Fi configuration. I'm telling it I want a web server on it. I'm telling it the debug level I want. Supports NNTP, so that's really nice because you can get the device to have its own time, get system time from the internet, which is very useful when you're working on microcontrollers. You might want to know what the time is, so you can turn lights on and off at a certain time. You can just imagine how useful it is to know absolute time on a micro. And then for this example, I've used one of his what he calls his light platforms, and I've connected a RGB addressable RGB NeoPixel to it. So let's flip to the desktop quickly. Here is the device we're going to work on right now. It is a ESP32 development board over here, and I've got 3 wires coming out of it to this addressable RGB pixel. So for those of you who don't know about individually addressable LEDs, they're really, really cool. You can buy them individually, or you can buy them in massive strings. And they support an interesting protocol where you can basically address each of the LEDs individually. And when you address them, you can tell them what color to be and what brightness to be. So if you've ever seen those really, really cool Christmas light displays, or when you see these light displays that change colors and change patterns, they're all driven by these individually addressable lights. So I've just got one connected here. But just to show you the power of this firmware, he has a whole subsystem to drive those RGB lights. And so you could make your house super interesting if that was your thing. Okay, so I'm going to plug this dev board in. You can see the LEDs come on and doing a bunch of crazy stuff because I've programmed it before. So I'm going to take you through the process of how you program this thing. So effectively, I'm going to take this YAML over here, save it to a file. All you need to do is save it to a file. And then he's got a very simple, he's basically made the process of compiling this thing really, really idiot-proof, if I could put it that way. So all you do is you type ESP home after you've installed the prerequisites on your machine. So basically, it's a Python install to install ESP home. So you pip it. Once you've got the install going, there are a couple of dependencies, something called platform IO, which is the stuff that does all the heavy lifting. So that's the C++ compiler and the code generator, all lives inside the platform IO platform. And he's just orchestrating that with a bunch of templates. So I'm going to say ESP home. Actually, let me just do this. And I've got it in a command file. So I said ESP home. I passed the YAML file in, and I told it which port to upload it as after it's done the compile. So you can follow along what's happening here, right? It's done a compilation of that. It is now generating the firmware by compiling all that C++ code. So it injected a whole bunch of C++ code. It is then creating a binary. The binary is then looking for my controller. So I need to get my controller into program mode. And if it finds my controller in program mode, it will upload the firmware to the controller. There it goes. So what we've done here, we've created a very specific binary that's got my Wi-Fi credentials in, my configuration, and we're uploading that binary to this device. What's really nice about that is that it's very optimized because it's got only your specific configuration in. And it's protected against any kind of weird corruption that can happen on these devices. So if the device ever resets, it's got my configuration baked into its binary. So for, I guess, more mission critical stuff, this is really nice because even if you reset the device completely, it comes back with your configuration. Okay, so once I've flashed it, again, it's speaking via the serial port to that device. So you can see that my device has come up. It's done a whole bunch of connections. I'm just going to try and find its IP address. There we go. You can see it's connected on that IP address over there. If we bang that into our browser now, you can see we're getting served as a very simple web page. His web page is not very powerful. But you really don't need a great web page on this because it's got a great API behind it. So this firmware has a full REST API support, as you can see listed on the web page right here. So if I pop open my favorite REST client, Postman, I've prepared a little URL that we're going to post there, a little REST URL. So you can see there's the IP address. I'm going to tell it I'm going to speak to the light NeoPixel light. And if you went back to my configuration, you can see I had a light on it. And I said the light was called the NeoPixel light. So the REST API is just taking the name from my configuration. I'm going to turn the light on, and I'm going to turn it on with rainbow effect. So if I go to my desktop and I show you my NeoPixel and I say send, I get a ACK back, and you should be able to see my NeoPixel now changing really cool rainbow colors based on the control that I sent over the REST API. Of course, I could go back to the web page if I wanted to, and I could turn it off, and you can see that my pixel is off. I can turn it back on, and now it's back on. Okay, so let's go back to slides. So how have I used this? I thought I'd try and make it a little real for you. The first example I have, a little personal example. My daughter has a Siamese Chinese fighting fish. We've had it in a bowl for 8 months, and all of a sudden we realized, jeepers, this fish is getting cold and winter's coming. So I used the Tasmodo firmware, built a little device, put a light globe in a tube, stuck it in her tank, stuck a temperature sensor in there, ran that very same rule that I showed you just now around temperature sensing. And now our fish Chi-Chi has its own heater that controls, let's see if I can find Chi-Chi's heater, that controls Chi-Chi's temperature. So you can see Chi-Chi's heater is over here. You can see Chi-Chi's running at a nice cool 23.4 degrees. And that controller keeps Chi-Chi nice and warm during the winter. So it's pretty interesting what you can build when you start from scratch, right? A little bit more of a mission critical one was I built an irrigation controller to control the irrigation in the house. I chose to use ESP Home for this one because I wanted to make 100% sure that if the device was ever reset or reboot, that it didn't randomly open my water pipes, which, as you can imagine, would cost a lot of money if we were just randomly watering the grass, if the controller went a bit wacky. So I used the ESP Home firmware to make sure that it really was a little more bulletproof, and that in case anything happened, we weren't going to drive a bunch of crazy water bills or turn on my pump when I didn't want it turned on. So you can kind of see here's my production system for my irrigation system. You can see there's a whole bunch of valves that it's controlling. I have a water flow meter, I have a water pressure meter, and I have a pump on there that I can control. Wanted to finish up with a couple of recommendations. Well, let me just let the slide build out. If you're looking to get into this and you want to do this type of stuff, the two devices I recommend are the Sonoff Basic. You can get them in a bunch of different places. The PyShop guys are really good. There's guys called SmartKit. I like the NetRAM guys are really good. The price you should be paying is somewhere between 120 and 150 bucks per device, which is really, really good. There's something called the Sonoff Mini, which is new, which has a double switch in it. You can flash that. It's a little more tricky to flash. Yeah, you can flash it, but the nice thing is that it fits inside a light switch really, really easily. There's some devices called Shellies, which I really like, made in Eastern Europe. Not that easy to get here, but they do ship. Again, very small. I have a bunch of those in some of my light switches. And the one on the right, the little black one, even has a power monitor in it. So it can actually show you consumption of your power consumption, and fully supported by Tasmoda. So it has an energy meter in it. So if you want to see how much your fridge is using or something, how much your lights are using, it'll give you real-time energy consumption, again, with the open source firmware. And then these devices at the bottom here are more of the dev boards. So both that fish tank heater and the irrigation controller were built using these little D1 minis over here. So not flashing commercial devices, I just used the standard dev device and then connected the solenoids to that. Cool. So that's kind of our talk. I'll do a bit of questions if anybody's got any questions. It's been, besides Candace's comment around the hoodie, I don't think that counts as a question. But yeah, thanks, Candace. You make great kit. Q&A, guys, anything. Smack it on the chat or break into voice.
How much power can you draw from that little transformer? So you had it, you know, the one you had connected to the onboard transformer. Like, is it light bulb level? Or could you get it to switch on your kettle in the morning and that kind of stuff?
Yeah, great question, Bradley. I think the Sonoff basics are 1 or 2 amps. So you probably don't want to put your kettle on it, but you can certainly run light bulbs through it. And you could probably, I mean, so what's that? It's probably near 100, probably 200 odd watts. So you can drive decent stuff on it. You could switch stuff with it. If you're going to go for a kettle, you probably need a slightly bigger relay. I've built something to control my geyser. So so if you really want to kind of see how far you can take it, I did that based on a D1 Mini. Yeah, you can with the right relay switch almost anything, right? I'll look up the specs of the Mini if you want. But yeah, it's a good question because you do need to be careful of that, right? You can't just assume that little relay will switch anything, right?
Magic smoke will come out rather quickly. Oh
yeah, it will. Yeah, and you also don't want to burn your house down.
No. Any other questions for Cliff?
I was just wondering, Cliff, why you hating the Chinese firmware?
Why do I hate the Chinese firmware?
Yeah, what did it do to you?
That's a loaded question, right? Without being too facetious, no, I mean, being deadly honest, and they're not all Chinese, right? And the Americans have their own flavor of it. There's a bunch of American devices. The problem is with the commercial firmware is that there's normally a billing model that is over and above the device that they try to push you into, right? So what happens with most of these devices is there's normally some type of cloud subscription service or cloud value add in quotes that they try and get you into. And unfortunately has been proven with many of these guys is that once you're in their ecosystem, they own you, right? So there's been a couple of devices where they've kind of sold the devices at a really good price. People have adopted them into their houses, and then all of a sudden they just change the pricing model underneath you. So what I like about this is that it's kind of all your own stuff, right? We haven't got into the sort of the controller side, which I covered at the last talk, but you know, there's another whole open source ecosystem on the actual controllers and the UI, the home assistant side. So with this, it's all open, it's all under your control. There's no like lock into a large vendor that can change the pricing underneath you. And so I think your investment is reasonably sound. The second thing is, I kind of mentioned it, is that it's cloud-based, most of these other guys. So to turn your light switch on from your phone requires a trip up to the cloud somewhere in China or the US and to come down. And so you kind of get that 2-3 second latency turning a light switch on when you're in the same room. With this kind of stuff, it's all local loop. So you're as quick as your local Wi-Fi, as good as your local connection is. And it just makes it a whole bunch easier. So there is kind of a real reason behind it. Not that I have anything against Chinese people, except that they gave us a very dodgy disease.
Would you recommend a Wi-Fi mesh to make sure your whole house have Wi-Fi, or just normal routers and relays?
That is an excellent question, and whoever asked that question is going to get the prize today. So I don't know who that was, but stick up your hand.
I can't get that prize.
Oh, I'm not saying who's asking. Damn it. Okay, somebody else asked that question and we'll get a prize. No, so great question. You know, the premise of the backbone comms on this thing is Wi-Fi. So it works as well as your Wi-Fi is. Meshes are great allies for great coverage. I personally use Ubiquiti stuff, so not mesh, just the Ubiquiti APs. But yeah, again, one AP throughout the whole home. So I guess a prerequisite for making this work really well is good Wi-Fi. And recently the meshes have got really good. I mean, the TP-Link stuff is fantastic. I've got a whole bunch of my friends onto TP-Link and my colleagues. And yeah, that is really working well with these microcontrollers. You know, the other thing over and above the coverage is just the number of devices you have on your network. I think at the moment I have about, let me check, about 70 or odd devices hanging off my home network. So you need a Wi-Fi mesh or a Wi-Fi network and controller that can handle that many devices. Because if you can't manage that many clients, you're also going to run into problems. And unfortunately, once you get into this stuff, these things tend to be like popcorn, right? You once you pop these things into light switches and pumps and controllers, they breed like rodents.
That's funny.
I have a question. Do you have any plans to perhaps like consolidate, like you were saying now, they just grow and grow and grow? Is there no way for you to like have all of your light controllers controlled by another controller, perhaps, so that you have like hierarchy and stuff?
Yeah, good question. So there are those architectures. So some manufacturers will do a bridge effectively, and then bridge into some type of proprietary control protocol that's not Wi-Fi. So, well, not always proprietary, but Zigbee is quite popular. There's just kind of standard 433. So just, you know, like how a remote control on your gate works. So Sonoff have some devices like that as well. And then they just literally put a bridge down. So you have one Wi-Fi point that then understands how to bridge it into the other network, if I can call it that. Xiaomi also does it like that. So Xiaomi has gateways into Zigbee, and they use what's the other protocol they use? It'll come to me. So there are those architectures. It just depends on kind of like which bunch of devices you want to back. I kind of made the decision, and I kind of looked at the cost and the economics when I did it in my house, that it would be cheaper for me to just buy simple Wi-Fi controllers and do a good Wi-Fi network than buy a bridge and more expensive controllers. So, you know, some of the other controllers are sitting at about $600-700 a light switch, and that starts getting a bit cost prohibitive. You know, Z-Wave is kind of there or thereabouts, which is the other protocol I was thinking of. So it comes down to cost, but your question's bang on, right? There are different architectures to minimize the number of Wi-Fi things on your network.
Cool.
Any other questions? You can just unmute yourself.
Yeah, don't bite, eh?
Chat if you're shy. And they can see if we can get someone to win a prize again.
Yeah, one more question for a prize. Well, while we're waiting for that last question, I'll quickly show you, if you want, kind of how this thing can turn out, how it can become a. So here's my UI of my home. You can kind of see I've got inputs coming in everywhere, right? So I've got temperature from the pool, rain gauges. I'm automating my energy usage. So I've got I'm looking at the amount of energy coming in the house, so you can see how much power we used a day over the last week. You can see the current temperature of the geyser. So built a little weather station using the same temperature gauge technology. So you can really take this thing to the hilt, right? And once you go, it really becomes super interesting. So question, what is the most popular chip that I talked about today? Does anybody remember the model number? And I'm watching the chat feverishly. Yes, Rudy, you're the winner. Rudy van Staden is our winner.
Done. Unfortunately, Sean, you can't get it again. But Rudy gets it.
Oh, Sean actually got there first. Bloody hell.
Yeah.
Sean, you can't win 2 prizes though.
Unfortunately. But well done, Sean. Cool. Well done, Rudy. Neil over there, what do you do for switches like light switches? Do you primarily use web mobile front ends, or was that what you're showing now?
Oh, you broke up for a second there, Brad. What was that question?
There's a question from Neil over there. Switches like lights, or do you primarily use web or mobile front ends?
Great question. Okay, so geez, if you asked that question earlier, we would have given you a prize. Or you did ask it earlier. Maybe we should give him the prize. Don't we have another one? Can we give Neil a prize? Okay, let me stop being facetious and answer the damn question.
No, we can give it for that question, because you're right. We said questions and he got the question in, and then we threw one out. So
cool.
It's cool. I've got JetBrains licenses. It's fine, thanks.
Oh,
hi Cliff, how you doing?
How's it, man? Good to hear from you.
Yeah.
So the Neil, I call it the wife and kid adoption factor, and many home automation oaks do call that. So what you want to make is that you do still have a physical light switch. So if I flip back to my desktop for a second, I think you should be able to see it now. Yeah. So this device over here, I've just plugged a temperature sensor into it. Actually, because it has a serial port with a TX and an RX, you basically have 2 ports on here. So I said that I've made temperature sensors in some of my rooms. I have, but what I've also done is taken a wire out of that and put it into a switch. And so it still traditionally works exactly like a traditional light switch. If somebody walks into the room and pushes the button, the light turns on. But it's overloaded with the web view and the smart controller view, so that if I go to my my light page over here, and I go and show you guys this page, and I switch my my lights off, you can switch the lights on and off, right? So you should be able to see if I do that. You should be able to see this. You can see the lights turning on and off, right? So basically what you want is you want the best of both worlds. You want a physical switch that works like everybody expects it to, and then you want it overloaded with a web or controller view that you can do smart stuff with. That way the adoption is really good, because if you try and just get everybody to take their phone out, to turn the lights on when they walk into a room or when they wake up in the morning, it's not going to last very long until your wife tells you to take it out, or your girlfriend or whoever tells you to take it out the house, because people are just too used to pushing buttons on walls. So you need to integrate it into a wall switch, and it's literally very easy. I mean, you just go into the configuration and say one of those inputs is a switch, and it becomes a switch.
My problem is that I run out of switches on the physical switches. So I've got a number of devices. You're sort of constrained to about 4. If you're lucky, you get a 6 switch.
So yeah. So Neil, what you want to do is you want to overload the switch. So now, because you have a brain controller sitting in there, you can overload the switch. So you can overload click and hold. You can overload double tap. You can overload triple tap. So one switch can become 3 switches.
Okay. Makes sense.
Yeah. So I have lots of switches in the house that are kind of, in quotes, smart switches. So like in my entrance hall, when I double tap the switch, it opens my garage door. It's probably just created a big security issue, but
yeah. Cool.
But does that make sense, right?
that
You kind of get the power of what you can do now, because it's not just a simple on-off switch.
Yeah.
And that way you can get by with having far fewer switches than you otherwise would have. Because you're right, it gets limiting after a while.
Yeah.
Or you must just put a controller in every single light switch, which is actually what I did. Then it works exactly like it used to work, right? Every switch is still the same switch that it was for that house, for that light, but you can do other things with it.
Cool. Thank you.
Rudy has a question. Do you have any clever ways that you've used your home automation to make life easier during load shedding?
Yeah, kind of. Let's go here. So if we wait 24 minutes, it'll tell me how many kilowatt hours I've used of my battery when my load shedding kicks in. I do other smart stuff like when load shedding kicks in, because I have a UPS in the house. So I do have a UPS. I then minimize so here's the UPS power. I'm using 560 watts at the moment. When load shedding kicks in, I know that the power goes off. So first of all, my phone sends me a notification that I've been load shed or that the power stripped. Then I kick in an automation, and the automation turns off all non-essential lights and things, so that I can make sure that I don't drain my batteries or my UPS quick enough. Yeah, so that's kind of what I did.
Very cool.
Yeah, that's pretty. Sorry, go ahead, Josh.
No, yeah, I just want to say that's very cool. I actually had another question, but if you wanted to speak on that, no, Bradley, okay. Yeah,
no. Go. If there's another question, go for it. Let's
go, Josh. Go, Josh.
My question was whether you could perhaps do like a tablet per room to get around the whole physical switch thing. So you could perhaps like mount a tablet where your light switch would have been, and then that could have the switches for that room and so on. Because this UI, I'm assuming this UI is editable, the lights UI like page that you were showing here earlier.
For sure. So good question, Josh. I do have a bunch of tablets. I basically repurposed a bunch of old iPads that I had. I stuck them to the wall. And in my kitchen, actually, I have a nice big 32-inch touchscreen, because it kind of becomes the dashboard for the house. So it's actually super interesting once you have all of this data, right? Like, so this view over here is kind of like the house's, the home's home view, right? And the kids use it, like we look at the weather and we turn things on and we open the gate and all of that crap, right? So that's really nice in the kitchen. The issue with having a tablet in every room is, well, I guess if you have a whole bunch of old tablets, you could maybe do it, but it's also like, it's not as intuitive, right? Because the things go to sleep, and maybe you don't want them on the whole time, because I've burnt 2 tablets out now because their screens were on permanently. So that like didn't work so well. The iPads are much better. The iPads can run for a long time, but I had some cheap Windows tablets that just literally melted. Like the screens just stopped working after a year. But it's not as intuitive, right? Like you walk into a room, like you're just used to hitting a light switch. So it can work, but I would say it works in kind of in public areas like your entrance hall and your kitchen. Like I don't think it's feasible to do it in every room, right? There's other ways to do it in every room. Now you can get smart, right? Like what I've also done is I've hooked this thing up to my home alarm, right? So I have sensors here for every, so basically every room has a PIR in it, and because the home alarm system comes into this, I can tell motion. So you can, when I walk into a room, I can tell it to turn the light on. So that works pretty well. But then sometimes you get into interesting situations. You don't always want to do it, right? When I go and check on the kids at night, I don't want their lights turning on. So like you get super, like the exception cases start building pretty quickly. Now, I mean, the other nice thing about the ESP32 is that it has a Bluetooth stack built in it, and some guys are messing quite nicely now with Bluetooth presence detection. So that's doing some interesting stuff. Like if you can really tell who is where in the house, then you can really do interesting things, right? If you know that I am in this room and it's me, Then you can start writing rules to do specific stuff. But the absolute presence detection is still, it's tricky, but it's getting better. But I'm answering your question in a very long-winded way. I don't think a tablet in every house is going to work. I think your girlfriend's going to beat you if you try that.
And then for the switches, is it like a toggle switch that you use, or is it like it's a switch that just has a button and you push it?
Hang on a second, and I'll show you what I've done. Where is it? Here. Yes. Okay, so I use these kind of guys. Actually, so it doesn't matter, to be honest. The Tasmota supports 2 types. Let me see if we can do this quickly. Then I'll show you the physical switches. Where's our... What was the IP address of that damn thing? I think it was here. I think it was this guy, wasn't it? It's still up. Yeah, let me show you the screen in the meantime. Okay, so here is the here's the type of switch that I support, that I use. So it's just a standard light switch. You can use either a rocker, so you know, an on, off. Actually, what I ended up doing was I ended up going this way. So same type of switch, but this is a press to make. So it's a 1 click, right? So it always returns to the home position. I ended up using this because if you use the rocker switch, Tasmota does support it, but then you get into an interesting situation where you turn it on with the switch and you turn it off with the controller or with Wi-Fi or with an automation. And then the switch is in the on position, but the light is in the off position. So you never really know, like, is it on physically or off? So then I decided to just use the press to make switches, which means the switch always returns to the home position, and then it's a toggle. So when you push it, it turns on. If it's on, if it's on and you push it, it turns off. That seemed to work really well. So I replaced all the switches in the house with these press to makes. Instead of the flip switches, but the flip switches are just equally well supported. It just has that weird anomaly that on is not always on, right? And I guess people get used to like, when I walk into this room and I push the switch down, it's on. Now, I mean, I think most of us have double switches in the house, which has that weird anomaly when the one is on and the other one is off. Then it's going to work like those double switches. But that was just my experience. Trying to make sense? Deathly silent.
Okay. Yeah, cool. I think we probably should wrap up now. And I just want to say thanks to Cliff and Shahzaad for presenting today and showing us some cool new things, how to get rid of your boring work at work, and then also how to make your home into a robot, which is great. And I know what I'm going to do with some light bulbs pretty soon.
Yeah, cool.
So that looks super cool. And we got one more JetBrains prize to give out, and we're thinking we'd like to give it to someone who's attending DevUG for the first time. This is your first time attending. Please speak up or type up, and let's see who gets that. We'll move on to something else. Anyone here for the first time? De Villiers, congratulations, you won yourself a prize. And can you just pop me your email address and we'll send it off to you. But thanks again to everyone for attending. This was a great demonstration as well. Like you said, it's not really what software developers normally look at, these hardware things, and it's really cool. I'd like to say thanks to our sponsors, and obviously for the prizes, JetBrains. And if you want to talk, or if you know someone that's got something interesting to say, please drop us a line on Meetup or on Twitter and let us know. Even if it's your first time, you can speak for 10 minutes and start getting your way into giving public speaking. But thanks so much for attending, everyone. And we'll see you again next month in September. I think we're probably going to be online again, but we'll let you know as soon as we can do this safely in person. Thanks so much again, everyone, and cheers and have a good evening.
Cheers, Bradley. Cheers, everybody. Thanks.
Cheers. Bye.
Cool. Thanks, everyone. Bye.
Cheers. Thanks.